Welcome everybody. We've been given this question. So foremost, let me show you the figure. At this particular point where the line, you have this line, there is a stretch of line that you can see here that is actually hitting the circle. So there is a point of tangency here T1 and a point of tangency here at T2, point of tangency T3, T4, T5 and T6. So these are the points of tangency. So we would have to utilize two important theorems. Now the first one is referred as the tangency of the circles theorem. It is also sometimes called as the radical axis theorem. So what is the statement of the theorem? When two circles have a point of tangency, then the line passing through that point of tangency will connect the two centers of the circles. Okay, so there is a point of tangency here. If I were to pass a line through this point of tangency, then that line would connect the centers. So there is a point of tangency and I pass a line through it, it's connecting the centers. Okay, fine. Now clearly the circle has a diameter 4 or diameter of 8 meters and the radii is 4 meters, right? So this distance is 4 and this distance is also 4. So that means total length of O1 and O2 is going to be 8. Now similarly, this distance from O2 to the point of tangency is 4 and from O1 to the point of tangency is 4. So the total, so this is going to be O2 to O3, right? So I need to specify it O2 to O3. So in this case O2 to O1, that's also going to be 8 and similarly O1 to O3, that is also going to be 8. So all the lengths are going to be of 8 meters. So this entire length is going to be 8, this entire length is going to be 8, and I've already mentioned to you that this length is also 8. So what do you call a triangle of equal lengths? So let me write that down clearly. We have a triangle of all sides being equal to 8 meters. So this means we have an equilateral triangle. So what is the angle of equilateral triangle? with O1 equal to O2 equal to O3, angle at O1, O2, O1, O2, O3 being equal to 60 degrees. So each of these angles is 60 degrees. So that is the first important step towards solving this question. Okay, now I will have to use another theorem. So this is called as the tangent radius theorem. Tangent radius theorem, or simply referred to as the tangent theorem. When a circle has a tangent, then the angle made with the radius and the tangent is always 90 degrees. Okay, it's always what? 90 degrees. So there is a tangency at T1. This is how we started, right? So if I were to drop a exact perpendicular or exact line, that would be a perpendicular to the point of tangency. That's the understanding. So a line drawn from O1 to the point of tangency will always make an angle of 90 degree. This angle is going to be 90 degrees. So similarly, if I were to draw a line from the radii to the point of tangency, then that would always be a 90 degree drop. So this is going to be a 90 degree drop. Okay, so this is making an angle of 90 degree, and similarly you have a 90 degree drop here, a 90 degree drop. Okay, so okay, a 90 degree drop, and there is also a 90 degree drop here and a 90 degree drop. 90 degree drop there and a 90 degree drop. Okay, so this from here to here, it's a 90 degree drop, or I would say when we connect it, we are getting a perfect 90 degree there. So this is 90 degree, this is 90 degree. Okay, that's a very important observation. Now this length is already 8. So if we were to drop a line like this and it is a 90 degree drop, clearly this length will also be 8. So similarly, this entire length is 8 and this is going to be 8. This is also going to be 8. So clearly what you see here, we know the radii, right? The radii is already 4 on both sides. So this length is 8. So what do we have? We have a rectangle, a perfect rectangle here, a perfect rectangle, a perfect rectangle. Okay, so each of these angles are going to be 90 degree. That is the eventual conclusion that I wish to draw to in solving this question. Okay, so that is the second step in this question. So now comes the final step where we find the length. So the length of the pink rope is going to be, we can start with this length, right? T2, T3 plus T4, T5, right? Plus T6, T1, which is equal to, okay, this is 8, this is 8, right, and this is 8, right? So we have got this length, and this length, but we need to evaluate the curve. So what is this? This is going to be equal to 24. So let this be equal to A. So length of the pink rope, this is just one part, okay? So we have only got the first part, we need the curve part. Okay, so I will write this here, straight line part. Okay, straight line. Now the curve part. So what do you see here? You have a 90 degree. What is this? 60 degree. And what is this? This is also 90, because we have already established that these shapes are rectangles. So what is this angle going to be? This is 90 plus 60, that's 150, plus again, let me write that down, 90 plus 60, that's 150, plus another 90, what is that? That's 240. So from 360, you take away 240, what do you get? 0, 2 and 1. 120 degrees you're getting. So this length is 120, and what is this length? By the same direction, this is going to be 120, and this is going to be 90, this is 60, this is already 90. So what is this angle going to be? 120. So we need to, why am I explicitly stating this angle? Because we need this region, right? We need this region, we need this region, and we need this region, because we have already found the length. Okay, we need to find the length of the curve part. The length of the straight line part is already done, but the length of the curve region has to be obtained. So for that, the sector has to be got, right? The area of the sector has to be obtained. So that's the reason I am determining the angle, the sector angle. Clearly I see 120, 120, 120. So how many 120s are here? 3 120s. 3 zeros are 0, 3 2s are 6, 3 1s are 3. 360 degrees I am getting. So if an image has 360 angle, what do we call it? We call it a circle. So we need the circumference of this circle. So what is the formula for circumference? So let me write this down. Circumference formula is 2 pi r. But what is r? R is equal to 4 meters. So therefore circumference of the circle is going to give me 2 times pi times 4 times, which is equal to 8 pi. So it's the total length of the pink rope is equal to what? For the first phase, what did we get? We got 24. So 24 positive 8 pi. And this is going to be the length. So units. Right? So that is the final solution. Now if you want, you can take pi to be as 3.14. So 8 times pi is going to be 8 times 3.14, which is 8 4s are 32, 3 8 1s are 8, 9 10 11 1 8 3s are 24 25. So you add this, you get 94912. So 4912 units. Okay, so in this case we are dealing with meters, so 4912 meters is the final answer for this question. Thank you everybody. Please like, share, subscribe.